Now, where it shines really amazingly well, those are the sporadic workloads. That's just amazing.
This is DevOps Paradox, episode number 66, AWS Lambda versus Google Cloud Functions versus Azure Functions for 2020. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Viktor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Viktor made me do it. Here are your hosts, Darren Pope and Viktor Farsic. Now, over the course of the past few episodes, we've been talking about serverless. And recently, Viktor just finished up the functions as a service section of the catalog course and book. And we figured now is a good time to talk about his experience a little bit more in depth of how he feels about functions as a service as they exist in 2020. Viktor, what is your feeling?
So to begin with, I think that it is mature enough. I think that functions as a service, if somebody wants to use functions as a service and was worried whether that is mature technology, mature service, I think that we are there as industry. And you can see that by differences, or to be more precise, lack of differences between different solutions on different providers. So the big question kind of whether we should use them, whether they're mature enough, short answer is yes. Whether we should use them, that's a longer answer. But I guess let's start first with comparison between the three, right?
Yeah.
Azure,
let's name the three.
So it would be Google Cloud Functions, Azure Functions, and AWS Lambda. Right? So they're all managed functions as a service. And I think that if we cover those three, that is representative of managed functions as a service in general. Now, this would exclude any other type of serverless, and this would exclude completely self-managed serverless, including functions as a service, right? So we're focusing on managed functions as a service flavor of serverless in the big three provider.
Okay, so who do you want to start with first?
I mean, we could do. Let's say that we start by feature and then comment on how they fare between the three. So, for example, one of the things that many must be interested in is to begin with which languages are supported. And like in Google, that would be Node.js, Python, Go, and Java. In Azure Functions, it would be C#, JavaScript, F#, Java, PowerShell, Python, TypeScript. And AWS supports Java, Go, PowerShell, Node.js, C#, Python, and Ruby. So if you look at it from that perspective, then Google Cloud Functions are the big loser of that, right? They're the only platform, only service of that kind that supports less languages than others, only 4. At least today, right? That might easily change in the future. But on the other hand, I could just as well argue that supported languages are not that important, because you should be able to actually switch to whichever language is supported, because we're talking about functions. We're not talking about developing something huge where the choice of the language is really important, mostly because you would get lost in a language you don't know, right? And then we can also enter into the discussion whether actually other languages should be supported. Like if I look at Google Cloud Functions, I get Node.js, Python, Go, and Java. If I exclude Java as being probably a silly choice for a function, then actually I could say that, yeah, Google supports only 4, but 3 that really matter in this context are supported. And then I could even argue that actually the loser in that story is Azure, because Azure doesn't support Go. And Go is definitely a good candidate for something as a function, simply because it is extremely efficient, extremely fast to start, and so on and so forth. That does not necessarily make Go better than Java or worse, but for something that is supposed... Now, actually, the important thing to understand is that every time you send a request to functions, a new instance of a function is spin up. Or maybe it was kept warm for a few minutes, the last one, right? But potentially, let's say potentially, not necessarily always, you get a new instance of your function or application. And yes, you can, if you go to Azure Functions, you can make those functions be written in F#. But do you really want F# as a function? Something that is supposed to start within milliseconds. No? Like, if you're building a traditional application that will run for hours or days or even months, it doesn't matter really whether it takes 5 seconds, 5 milliseconds, or 5 minutes to start. Right? Because it is a worthwhile investment to wait for a while for something that is going to run for a long, long time. But for functions, probably you want to go with JavaScript, Python, Go, right? And in that case, it's all the same. Doesn't matter which are supported, because they're all supported, with the exception of Go not being supported in Azure Functions.
And just for transparency, all the testing that you did was with JavaScript.
Yes.
Okay.
Yes. And now, when we're about testing, and this is kind of what shows maturity of that technology, I could not detect any reasonable discrepancy in the results between those three, right? They're all more or less equally fast. They don't show considerable lag in initialization. They can handle a potentially huge workload, all the good stuff, highly available, what's not. So they're all equally good as long as you're not building something like, let's say, in Java or C#. That's really a bad idea.
So languages, if you throw it out there, the only one that's really questionable is lack of Go support on Azure today.
Yes.
And today is in July 2020.
Yes. But at the end of the day, no matter how much I'm saying that it shouldn't be problematic to write your functions in any language, no matter how experienced you are or no, the chances are that people are going to look for a solution that works in their favorite and potentially only language they ever worked with. And in that case, pick kind of check whether your language is supported or no, and then just go for it. Wherever that works.
Just go for it. I see what you tried to do there.
There you go. That's subliminal messages.
Okay, so languages. Effectively, they're roughly all the same.
I mean, Google supports the least number of languages.
But they support the core number, right? They've got
yes,
JavaScript, Python, Go, and Java.
Exactly.
Those four are good. And then if, much like Azure has added PowerShell and F#, that's great. That's the Microsoft ecosystem, right? Easy onboarding. And then AWS has just been out there the longest.
Exactly.
They're all okay.
Exactly. No. I mean, unless you're really eager to work with a specific language, then. But okay, I'll get to that later. Actually, so I mentioned high availability. They're more or less. Actually, depends on how you look at availability. Google is kind of like maybe 1 second or third decimal behind. The number of nines. So with Azure and AWS, I got more nines, like 3 nines after decimal, right? With Google, I got 2. Now it wasn't some really deep testing that was running for days and stuff like that. Relatively quick type of testing of availability. So yeah, Google is a bit less highly available, which unlike languages might be a bigger deal breaker than, I mean, that might be a more important thing. Now it all depends really on how you set up your system, whether you have retries on your upper level applications or functions or what's not. But yeah, if high availability is important, and it should be, then again, Google is a bit behind when functions as a service is in question.
And define high availability for us in a functions as a service scenario. How did you define it?
In fact, so basically, how many requests? Actually, there are 2 things you want to look for. Generally speaking, is whether you run multiple replicas of something and that is spread across zones and all those things. But that does not really matter in functions as a service, because those things are obfuscated for you. You don't know really where your functions are running. You don't know much about them. So the only way you can really observe availability of functions is by bombing them with requests and see how many failed requests they receive, right? You cannot observe the system in detail to do something deeper than that, right? You cannot kill a function in the middle of the process and see whether some other function will take over. You don't have those tools at your disposal. So the only thing that I can come up with is that, yeah, let's do some form of performance testing, bomb the solution with huge amount of requests, and see what you're getting, right? And then they all work fairly well, with, as I said, small difference when Google Functions, negative difference when Google Functions is concerned.
So from your perspective, you were checking for a non-200 response code?
Exactly. See, I mean, application that is decently, function that is decently small, not necessarily with all the bells and whistles that many are not gonna put inside. Just simple function, bomb it until there is no tomorrow and see what you get.
Okay. We've talked about language. We've talked about availability. I'm not even going to say high availability, but we've talked about availability. What's the third thing?
I mean, there are small things, like, for example, one thing that I like default values being sensible, right? I like that a lot. And for example, Google Functions are secure by default, meaning that nobody can access them except the person you give privilege to do that, or a process, while others are kind of available to all by default. But again, that's such a small difference, because it's more about default values. In all of them can be secured, all of them can be monitored. You can collect logs from all of them. They all do the same thing. And then you can say, okay, so if they do the same thing, that's complicated. How are we going to decide which one is better than the other, right? And then we would probably enter into the story of the cost. So which one is cheaper? And again, the answer is none of them. They're all equally expensive or equally cheap. The difference is I poked in different scenarios, and the differences are really minuscule, depending on the memory and CPU you assign and how many you have in parallel and so on and so forth. The differences can be, let's say, 10%. But 10% of a cost difference, which I know that if we're talking about millions of dollars, can be huge, but 10% is almost certainly not significant difference for anybody to choose one over the other, as that being the primary choice. That's probably just not enough. Long story short, I could not find a significant difference, something that would make me say, this one is so much better than the other. And then that leads me to conclude that most likely there is no real competition, because you're going to use a service of your favorite compute provider, right? The situation is not like with Kubernetes. With Kubernetes, I could argue that if you're running today in one, there could be a significant reason for you to switch to another. But with functions, if you're, let's say, running in Azure, you have no incentive to go anywhere else. Or the same applies to AWS and Google, right? So it's a depressing story. There is no real comparison because they're all equally good or equally bad. The only thing that you will notice is that, and this is now a shocker, that they are extremely expensive when running at scale. Like 5 times more expensive than almost anything else you can do.
Meaning versus a long-running process that can handle the same amount of traffic.
No, not necessarily long-running process versus relatively constant traffic. And what I mean by relatively constant traffic, if I said that this 10 years ago, that would be, you expect maybe, I don't know, thousands or millions of requests, concurrent requests, and you expect a variation of 10%, that would be a constant traffic. In my head, constant traffic is traffic that does not change drastically from 1 minute to another, right? So it's okay if you have 3 times more traffic in afternoon compared to morning, right? That still counts as a constant traffic. I'm more referring to those very fast variations. Like this very moment, you have 1,000 concurrent requests, and then half a minute later, you have 100,000. There you benefit greatly because, first of all, it would be very hard for you to scale that with that speed and that quantity yourself. By the time those oscillations, you cannot really easily scale hardware fast enough to handle those oscillations so that you get financial benefits of using less or using more. But if it's not such a high frequency oscillation, then it's very expensive, because let's put it this way. For each CPU you use as functions, you're going to pay 5 to 10 times more than CPU you use in normal way. So if it really depends from use case to another, but if you have a normal traditional running stuff, and your oscillations don't go more than double, you can just say, okay, I'm going to put double the servers and I'm still going to pay the same or less. Now, where it shines really amazingly well, those are the sporadic workloads. That's just amazing. Like, let's say if you would have CI/CD pipeline builds, they're very sporadic. You don't have normally thousands of concurrent builds in parallel. I mean, some do, but many don't. And the oscillations are amazing. Like, people come to the office and then they, first thing they do, they start building something and they don't do much for next 3 hours. And then 1 hour before they leave office, the number of builds increases drastically and so on and so forth, right? That would be, or ETLs or creating backups. Basically, almost anything that is a cron type job, either scheduled periodically or initiated through some event, that is extremely cost effective. Because if you want to run backups, let's say through cron jobs, right? You need a server there that will initiate that cron job. and maybe you have a couple of jobs a day, and you're paying the whole server for that. And that's where those benefits really shine, right? Sporadic workloads, I would say, would be the best candidate possible.
So the 1, 3, 5 times a day, great usage. The let me, because I've heard two things here. I've heard this cron job type thing, but if it's a cron job that's running every minute, maybe not. So or is that one okay as well? If it's running every minute, would that be a better?
So if it's running every minute, but let's say it takes 5 seconds, then yes, it's a good candidate, right? Because you have 55 seconds of wasted compute power. Now, if it's running every minute and it takes, I don't know, like 45 seconds, then it might be cheaper not to use functions as a service. Managed functions as a service, right?
And then the other one that you called out was the one for scaling for a spike.
Yes.
You were talking about sporadics and spikes. So if I'm going along at 1,000 requests per second and all of a sudden it spikes to 100,000 requests per second, I don't care if you're running on a Kubernetes cluster that has cluster autoscaling turned on. You're probably not going to be able to react. The cluster autoscaler is not going to react that fast.
Yes.
Or at least in July 2020, it will not react that fast.
Correct. But then how often does that really happen?
And it shouldn't. Well, if you're a news site, then that could happen at any point in time. What's a breaking news item? If you're Twitter, if you're something like that, it's informational type thing that would be very useful. But if you're a banking site, other than people rushing to transfer their money to different accounts, again, it may not be the right solution for a banking site. And I think that's the thing that we're talking about here in the language, in the availability, in the cost. Just because it fits right now doesn't mean it will fit for every use case that happens for what you're using it for. So be ready to spend money. You're going to pay money one way or the other.
I must stress also that my comparison might be unfair because while I do think that more often than not functions are very expensive compared to others. Now, you might have other savings that might actually make that cheaper. Maybe it fits your development model and the savings from not managing your infrastructure are going to be greater than the cost of that you pay to your vendor, right? So there are many other factors that is close to impossible to calculate on general terms and say this is cheaper, this is expensive. But if you look at simply the bill from your vendor, then it's expensive. Now it's up to you to subtract from that bill the other savings.
For an example, I've got an application that's doing 3,000 requests per second. I'm making a decision, okay, do I go Kubernetes or some sort of container as a service, or do I go functions as a service? So if I go containers as a service and I'm AWS today, I'm still probably going to need a body or two to help manage that in some way, shape, or form beyond just the developer creating a function and dropping it on Lambda.
I mean, if you go for containers as a service, you could use similar services in other providers, right? So management overhead would be the same with containers as a service as with functions as a service, or very low, let's say. Or at least if providers would implement containers as a service well. Now, I think we should save this for a different episode, but I think that actually containers as a service state is very immature. The implementations are horrible and really ineffective. but that's a question of time because everybody just started with those concepts. But what was to me interesting is that you mentioned that, I think you said service that has 3,000 requests or something like that, right?
Yeah, steady state 3,000 requests per second.
Yeah. Now, let's say that even it's not steady, but let's focus on 3,000 requests per second. Now, and forget about functions as a service and this and that, right? How effective it is, theoretically speaking, to handle each request with a different instance of something?
In general, it's not practical.
Exactly. So if it's some ETL process, let's say that you want to transform something in your database, maybe load some files and put them somewhere. ETL processes are perfect. Batch type processes are perfect. They're all single process, single job type of stuff, right? But 3,000 requests handling with 3,000 newly created processes, that is inefficient. That's horribly inefficient. No matter whether we forget about existence of functions or whatever, rarely anybody would come to conclusion that that's a sufficient way to do stuff for 3,000 requests. I'm just following your example.
We should add this to the list. And by the way, if you're listening to this and you haven't taken the survey yet about the catalog, there's a link down in the show notes, devopsparadox.com/survey. This is something we need to add to the list. We've talked about the functions and just generally the functions normal, right? The normal lambdas, the normal other two functions. We need to test functions on the edge. Yeah. Because that could be different. It may be the same from a step, but let's think of it this way. I've got a globally distributed application, and I'm just trying to capture data as quickly as possible. So it may be something as simple as I've got a little function on the edge that accepts the HTTP request, but what the function's really doing is taking the body of that request and posting it to a queue somewhere for later processing. We just want to make sure that we get the message as quickly as possible.
Yes. I mean, that would be a great example, for example. I mean, definitely. Edge computing really deals with that type of processes, right? Either very variable at the place where you're collecting it, or very sporadic, and in this case, sporadic at the source. Your edge devices are likely not going to transmit a constant stream of something.
Right.
I mean, likely. I'm really, there's like zillion type of use cases for, but that kind of brings us, I guess, to the key thing. Are functions useful? Yes. I have absolutely no doubt that functions as a service is a useful model. Where I'm strongly differ from many people is that I don't see that as being a model that carries significant percentage of a workload in an average company. Right? Kind of. I think that we mentioned that in a previous episode, like maybe 5%, maybe 10% stretch. Going back to the very beginning, if you focus on comparison between the big three, the good news is that use whatever is offered by your vendor. It's all the same.
So if you need to use functions as a service, mature enough, may not be cost effective, but might be, depends on your workload. And we haven't, and I'll say it this way, operationally, how does it change?
Basically, the only thing you do from operational perspective is really set up some infrastructure type of, initial things like VPCs in AWS or things on the edge of computing in a way, right? But everything else is just, deploy my function. Here's my code, here's my function, deploy it. Basically, most of the operations go into developer hands. Now, the part where operations or sysadmins will suffer greatly is very reduced visibility. So, when functions work, they're going by themselves. Basically, there is not much, if anything, for you to do. When things go wrong, try to trace a problem. Try to debug what's going on. Because now we're talking about you having two monoliths and then you switching to hundreds of microservices, and now we're talking about you switching to thousands or tens of thousands of functions without really a proper mechanism for you to observe, monitor, alert what's going on. And even if we would have a proper mechanism for that, it's still extremely complex. And that is the part that is, I believe, immature. And it is immature mostly because you rely on your vendor 100% fully, right? So you will not be able to leverage some industry standards. You will not be able to leverage many of the other tools. Some maybe, but many not. So you're at the mercy of your vendor. If they have what it takes, you're good. If not, you're going to be running blind.
Really, we see most of the time that people run blind anyway.
Yes, but at least there is a light at the end of the tunnel. I can tell people, yes, you're blind, but why don't you add Jagger for tracing? Why don't you add Prometheus for collecting metrics? Why don't you do this or that, right? Maybe go with Datadog. No, there are many solutions. So it's if you're blind by choice, mostly.
Right. Well, you've made an architectural decision to use a solution that doesn't support third-party observability.
Yes. And, you might be extremely happy with what your vendor provides. If you are, great, power to you, right?
Well, going back to my example of I'm capturing a JSON post and dropping it on a queue. I don't need a whole lot of observability in that. Either it works or it doesn't work.
Yes.
Right? But if my function, okay, I'm going to write to the queue and then I'm going to send a message to Slack and I'm going to, if you start fanning things out in a single function versus potentially decomposing those to other function calls or putting it onto other things, you've got to think a lot more clearly how you're writing your function. You cannot write a function the same way you write a normal application.
Exactly. And that's where we are coming back, I think, to the previous examples. If it's some batch type of processing, create an event and then function does something and that's it, or periodically run a function, that's all great. But if you're talking about you building a system like I think you were describing, that would be create an event received by a function calls three other functions call 7 other functions, it goes back and forth in a circle and then weird paths and all those things. Something goes wrong somewhere along the way there. What I just described, I think that those were the main and valid reasons that people were rejecting microservices for a long time. And when I say for a long time, I mean until last couple of years. Microservices are big today because those subjects are kind of better handled, easier to do. And I'm just not sure that I think that we have them covered for microservices, more or less. It's better at least, but not that covered with managed functions as a service. And repeat managed, just to clarify that I'm not talking about those that you would run yourself, because then they can follow the same patterns as any other type of application.
So this doesn't wrap up our mini serverless series. We're going to be revisiting it again, but for now, this is sort of the end of the serverless series, at least as a straight block. Next week's episode is going to be different. But then the next big up is containers as a service, right?
Yes. I mean, I can give a very quick TLDR. I think that I think that serverless are the future. And I think that CaaS or containers as a service are the most likely implementation of that future. And I think that FAS is not it.
FAS is great for single process. Again, your batch load, or if your type of traffic experiences highly spiky. So it's what were the two S's we had? Spiky and sporadic.
They're good for that if there is no equally good alternative.
Exactly. If those are candidates for you to look at going with functions as a service.
Correct.
It doesn't mean that functions as a service is the correct answer. But it might be.
Yeah.
Okay. That was functions as a service, managed, good grief, managed functions as a service.
It's so important to actually, I practiced to make sure that I always inject that word, because I got quite a few negative comments is, but this really, what you're just saying is not true for this or that. Because like OpenFAS, for example, it's self-managed, officially functions as a service, but it's not really functions, it's containers. At least as an input mechanism, and many of the things do not apply to it, and so on and so forth. So people were yelling at me, this does not apply here, this does not apply there. So Azure Functions, Google Cloud Functions, AWS Lambda, only those three.
If you would like more details and you haven't picked up the catalog course or book yet, go ahead and do that. The link for both of them, actually, it's just a link. It'll take you to a page, and you can choose which adventure you want to take, whether you want to take the course or if you want to read the book. Go see that down in the show notes, and we will talk to you again next week. We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.